fourth question on 2009 was pretty difficult. So let's take a look at it together. It involves something called a number tile, which, okay, just another user-defined class. So hopefully you're getting used to that now. We've seen it a bunch of times. Number tile has 4 numbers on it. They're assigned like a position on the tile, left, right, top, bottom. We can rotate the tile 90 degrees clockwise. We can get the value on the left or the value on the right, but I guess we can't get top or bottom without rotating it, but that's fine. We can still get everything we need. The tiles are put into a game board, which is just an array list of tiles, and that's just an indexed storage system, right? So, every tile has an index, that's its position within the board, and then we're going to try to put tiles into the board. So in part A, a couple of things that are important to note. In part A, we're not allowed to rotate the tile, so just whatever its current position is, we want to see if it fits on the board. There's a special case where if the board is empty, we need to return 0 in part A, okay? And if the tile can't fit on the board, we say -1. And they promise us here that they're only going to give us, like a valid number board, things like that, number tile board. All right, and if we look at part B, now we're allowed to rotate the tile. We're going to actually put it into the board, so we're going to use the array list add method. If we successfully add the tile, we return true. If they give us a tile that can't be added to the board, like the numbers just don't fit anywhere, we'll return false. And there's a little bit more detail on that coming up. Let's go ahead and take a look at part A first. Part A's got quite a bit of code, and the reason is there's some special cases that we need to understand. So if you look at the code in part A, we're going to have to allow for, maybe we want to put this tile in way over at the far left side of the board. Maybe we want to put it in over at the far right side of the board. Maybe it has to go into the middle. These are all a little bit different. If the tile is going to go somewhere into the middle of the board, it has to match on both the left and the right. So see how like tile 1 has a 2 on the left and a 2 on the right. It could insert itself between indexes 2 and 3 or between indexes 3 and 4. It's important to note here that if we're going to insert it between indexes 2 and 3, they want our method to return 3, which is the number of the tile on the right. It makes sense if we think about it, because if we insert our tile 1 there, the tiles currently at indexes 3 and 4 would have to shift right 1 each to make room for it. So tile 1 is going to essentially take over index 3. So that's part of the reason why they're telling us to return that index as opposed to say 2 or 2.5 or something. And then the other thing, like I said, there are extreme cases where we may go to the far left of the board or to the far right. So if we went to the far left of the board, we would only need to match 1 number of the tile, not 2. The tile's right number would have to match this board 0 tile's left number. If we're going to the far right, our tile's left value would have to match the board end tile's right value. Notice that if we did go to the far right, we'd actually be coming in at index 5, which is sort of a fictitious index in terms of the board. It doesn't exist yet, but we're allowed to do that. Remember, with an array list, you can always add to the end of the list. You can go 1 past the last current index. And so, yeah, there's that special case of 0 as well if the board is empty. So I wrote my code. I just went ahead and wrote out 3 special cases. Could we combine some of this? Maybe, but to me it seemed, pretty logical to just write 3 special cases. So here's my special case of an empty board. Okay, so if I have an empty board, they told me just go ahead and put it in at index 0. Okay. Here's my special case where if I want the tile to go to the far left of the board, in that case, my tile's right value only has to match index 0's tile left value. If I want to go to the far right of the board, then I want my tile's left number to match the board's last tile, okay, size -1, its right value. Notice that in that case, I inserted to size of the board. Okay, like we said, if the last index tile was 4, we're actually going to take over index 5, which would be the size of the board. 0, 1, 2, 3, 4, 5 tiles. Otherwise, I wanted to visit all of the interior indexes. So I'm not worried about 0, okay? That's on the far left. But index 1 potentially could become my insert index, or 2 or 3, or in this case 4, because remember 4, we could take over index 4 and the tile there would shift 1 to the right, or whatever size board we're dealing with. At that point, I actually made 2 comparisons. So I took my tile's left value, I went to the board and got a right value. I took my tile's right value and I went to the board and I got a left value. Here I'm looking at tile I minus 1, and that's because, remember, if I'm coming in here to say I want to come into index 1 with my new tile, I'm actually going between 0 and 1 on the board, okay? So I was looking to the left as I made this comparison, and then that way I could return I. I'm sure you could write a variation of this method where you return I plus 1. You'd have to restructure your loop a little bit, a few other things. If none of the special cases kick in, if our loop never finds an index to fit, then we say -1. That's our fallback value, okay? If all else fails, return -1. And notice that in my answer, you never see the word rotate, okay? So remember, we were not allowed to rotate in part A. In part B, we're gonna rotate. So in part B, they give us a tile, they say, go put it in, okay? Assuming that it fits, we'll put it in, we'll return true. Maybe though it doesn't fit, and we'll say false. The big difference here is we're gonna check all possible orientations. There's potentially gonna be 4, okay? So we're gonna have to allow this tile to rotate. We have to use our method from part A. You cannot recreate that code, so we're gonna trust this method to tell us where to put the tile. That method doesn't rotate though, so we're gonna have to handle the rotation in part B and then call that method a second time, potentially a third time, potentially a fourth time. And we should do that within a loop, okay? And then a couple other things in part B we should pay attention to. There's like these preconditions, post-conditions. Remember, preconditions are given, okay? So don't ask this question. Don't ask if the board's null. They're telling you that it's not, so don't worry about it. The tile should be placed at most 1 time. So you got to kind of watch out for an infinite loop. Anytime you're writing add or remove code, you got to be careful with how you index your loop. And then these post conditions, these are different than preconditions. This is saying like when you're done with this method, this stuff should be true. So like essentially it's saying don't mess with the board. Don't go move other tiles around. Don't shuffle them. Don't rotate them. Don't do anything silly like that. Okay. So in my part B, I wrote a loop that ran exactly 4 times because there's 4 orientations for each tile. I know that technically we only have to rotate it 3 times to achieve those 4 orientations, but throwing in a 4th rotate at the end really doesn't matter. I trusted my method from part A, okay? So go do the work for me. Here's that method from part A. Go do the work for me. If that method says -1, then I cannot put the tile into the board in its current orientation, and I need to rotate it. But as long as I don't get -1, I can add it at whatever that index was. If it was 0, if it was 3, if it was 10, whatever it tells me, I'll put it into the board there, and I'll return true. And the return true is kind of nice here because it shuts down the method, and I don't have to worry about adding this tile a second time. If my loop exhausts itself and I've run out of rotations, then I'll say false. I didn't bother with a special case for 0 because if it is going to say 0, like a size board 0, it's going to work itself out. My method from part A is going to return 0. On the first rotation, we'll get back 0, which is not -1, and we'll put the tile in at 0. Everybody's going to be happy. I wrote kind of a strange tester here for you. I actually borrowed it from one I saw online, and it just kind of walks through the original example in part A. So for part A, they gave us a tile that could have gone in at index 3 or 4. And when they say that, they mean it. Like if there's 2 possible answers, they'll take either of them. It's not like you have to produce both. It's impossible to produce both if you're returning an int. Okay, so don't try to do something silly. And then can you get it to print -1 if it doesn't fit? Okay, or return -1, I should say. At that point, I added 5 tiles in. This should look just like the example on the directions in part A. And so then to test part B, what I did was I tried to add 2 tiles. The first tile I brought in did have a way to add itself to the board, so it said true. The second tile I tried did not have a way to add into the board, so it said false. And then we don't see it actually added to the board. And you could go back and try, putting in some more tester cases if you wanted. I'd say this, on a scale of 1 to 10, this is like a 9 in difficulty. This was a tough problem. I mean, are we going to see a problem this tough on our test? I don't know. I mean, it is an array list. It is a user-defined class. It's got methods and control structures. I mean, we could, probably not.